So now that we know how to name cations and anions, at least if they're monatomic, let's go ahead and whip through a bunch of examples as a demonstration. First of all, something quite simple. If I saw this compound right here, first of all, I would know it was ionic because it's got a metal in it. And if it's got a metal in it, it's going to be ionic. You can count on it. So I know I need to name the cation, even though there are two of them, and name the anion. And the cations are sodium cations. And of course, I don't need to indicate the charge on a sodium cation. They're understood to be +1. And the nonmetal anion is an anion of oxygen, so we would use IDE as a suffix and call it oxide. So this formula is the formula of sodium oxide. If I take another example then, well, I know it's ionic because it's got a metal in it, and that metal would, of course, even as a cation, be called aluminum. And then I know that these are all anions of sulfur, and monatomic anions of sulfur are named by placing IDE as a suffix, and this is aluminum sulfide. Further example, if I were to see this, I know it's ionic because it's got a metal in it, and I know that ion would be called sodium, and that anions of nitrogen are referred to as nitride. But these are all relatively simple examples because you'll notice that I used always the cations that only have a single charge as cations, and therefore I don't have to worry about charge. So, for some examples where we do have to worry about charge, let's look at these. Now, in all cases, clearly, these are ionic compounds. We have iron, we have nickel, we have cobalt. Those are my cations. And of course, we have monatomic anions of oxygen, chlorine, and sulfur. So I know fundamentally this is going to be iron oxide and nickel chloride and cobalt sulfide. But in all three cases, it's an incomplete name if I simply call this iron oxide because there are two iron cations. So I know that I'd name the cation iron, but I would have to specify the charge of that iron cation in parentheses with a Roman numeral. And the way I figure out what that charge is I first figure out what the anion is. And the anion is a monatomic anion of oxide. Now, why do we worry about the anion before we determine the charge on the cation? Here's the simple reason why. You will always know the charge on your anions. For instance, if oxygen is in group 6, I know that to achieve a valence octet it needs 2 more electrons, and all the atoms in group 6 tend to form a -2 anion. So of course this anion in the formula is in fact this, oxide, O-2. Now how does that help me identify what the charge is on the cation? Very simply, the charges on the ions must add up to 0. We must have a compound as a whole that's electrically neutral. And if this one anion is -2, it means the one cation paired with it must be +2. So this is, in fact, an iron 2 cation. So the name of the compound is iron 2 oxide. Please note that the 2 is part of the iron's name. This is, in fact, an iron +2 cation. It has nothing to do with how many of the ions we have. I only have one of them. Doesn't mean I call it iron 1 oxide. It is one ion called iron 2, and the name is iron 2 oxide. Now, if we look at the second example, I do know that the cation is nickel, but since nickel is to the right of group 2, and isn't one of the 4 few common ones that has only a single charge, I am going to have to specify the charge on the nickel. And I don't worry about the charge on the nickel until I've identified what the anion is in this compound. And the anions are anions of chlorine. So of course I'm going to call them chloride as anions. And all the halogen anions form -1 ions, chloride for example. And the reason the formula has 3 of these -1 anions is that this must add up to a -3 charge on all 3 of them. -1 plus -1 plus -1 is -3. And since there's only a single cation neutralizing that -3 charge, this must also be a +3 cation. So now I know how to name the compound. This is nickel 3 chloride. Please remember, the 3 refers to the charge on the nickel. It has nothing to do with, coincidentally, that there happen to be 3 anions with it. Now, in this last case, cobalt is also to the right of group 2, and so I'm simply not going to call it cobalt. I'm going to call it cobalt something, and anions of sulfur are called sulfide, IDE. So, what is the something? What is the charge on these cations? Well, we do some simple math. Sulfur's in group 6, so I know that these anions are really these anions. Sulfur -2, sulfide anions. And the reason we need 3 of them is so that we'd have a -6 charge total in the compound. Now, if we have -6 total, for this to be neutral, this must be +6 total. +6 minus 6 would be neutral. And we have 2 of the atoms that are charged, and so they must each be +3 if they're going to add up to +6 for a total charge. So yes, because I know the 3 anions end up to -6, I know the 2 cations have to add up to +6, and if the both of them add up to +6, it means each of them is a +3 cation. So this compound is called cobalt 3 sulfide. And again, don't be misled by these numeric references. Those are not where the name comes from. I wouldn't call this cobalt 2 because there are 2 of them. I call it cobalt 3 because that's what it is. So a quick recap, if I were to say, see this compound right here, I would think ionic because I see a metal, and I would name that metal calcium as a cation. And of course, because calcium is in group 2, it's implied that it's +2. I would never say calcium 2. And then anions of phosphorus would then be called phosphide. And this is calcium phosphide. On the other hand, if I were to see this compound, yes, I know it's ionic. It's got a metal in it. And I know that that's a copper ion, but copper is to the right of group 2. It's right there. And it's one of those common metals that could have more than one ionic charge, so I'll get back to it in a second, but I remind myself I'll need it. And then I go look at the anion, and the anion of nitrogen would be called nitride, IDE, IDE. And then I think that since nitrogen is in group 5, as an anion, it acquires 3 extra electrons to have its octet, and therefore it's a -3 anion, which means that these 3 cations together add up to +3. Well, that means they each have to be +1 if 3 of them add up to +3. So this is in fact copper 1 nitride.